it will be international. Really, from I see right now from my website owner panel, there are about 35 different countries, including Italy, United States, United Kingdom, people from India, several people around the globe. So this is going to be international, and this is very good.
But do you have people in an auditorium?
Sorry?
Do you have people who are sitting and watching you?
No. I am just alone at home, and people are just on the web. Everyone is at air or his very own home. This is nice, no? So we are reaching everyone at home. This is good, familiar.
Okay, wonderful.
So I will leave you for a couple of minutes, just checking some technical stuff to see everything is ready, and you will understand when I will start, because I will start talking officially. I mean, so I will leave you here, and in 30 minutes after the beginning, we will join together the discussion. Mike.
Wonderful.
Thank you very, very much. And so I will leave you for a few minutes, and in 4 minutes, more or less, I will open the live event, and people will start hearing me, and then both of us together.
This is wonderful. The whole world.
Yes, this is the best thing we can do when we are under the stars, I believe.
All right. Well, have a good time. I hope everyone else has a good time.
Thank you.
I will stand by.
Thank you, Mike. I will leave everything ready, the audio opened, so you can listen, and when I will call you, I will invite you to join, you will be ready. And here we are, so happy that finally the time has come.
Yes, finally. Okay, I will let you go on with your work, and I will listen, and when it is time, I will answer your questions and speak.
Yes, it will be a very familiar conversation, because the questions I have sent are just were just intended to give you an idea, but I will not ask. I will just conduct together with you the conversation. It will be, I'm sure, very nice, and looking forward to that.
Yes, I'm sure there will be no problem, and together we will do a very informative job.
I'm sure. I'm really, really sure. So I'm going for a couple of minutes, and I will start everything. See you and listen to you later, Mike. Thank you.
Okay, bye, Jean.
going through the well, and just checking that everything is running just fine. So I see a lot of people there, so happy that this is starting so nicely with a lot of people from many different parts of the globe. Okay, I see the audio and is coming fine. So I really think that we can start this officially. So good evening, ladies and gentlemen, good day, depending from where you are on this globe. Gianluca Camasi speaking from the Virtual Telescope Project in Italy. Well, I'm very happy to meet you again for this long-awaited great live event scheduled for Asteroid Day, this global celebration just launched many months ago, you know, and right now arrived to its climax, and Virtual Telescope was asked to officially run this online event, and we were proud and happy to provide our technology and our knowledge. And as I announced, this special event will be very nice, I hope, for you, and I hope we will have some good time with us. And I'm also proud and happy to announce that we will have a great guest, which who I'm very happy to remind you, because I was so happy that he accepted to be with us, and you will listen to him later. He is Michael Schwartz, CEO and founder of Tanagra Observatories. He has been a pioneer and he is a leader about astronomy and robotic and automated astronomy, especially when discoveries and asteroids and comets are a very important topic. I'm so proud to have Mike with us because, as I said, for me he has been such a great reference, a great inspiration, and we will be talking with Mike later on from his home and observatory in Arizona. But before having the pleasure to be with him, I would like just to introduce you a few things, because this event is about asteroids. Well, let me say that asteroids are a very familiar topic for those following the Virtual Telescope Project, because if you consider all our events, for sure the larger part are about asteroids. We always like to really follow those close approaching asteroids, and let me say that the Virtual Telescope Project has been truly the world leading facility, tracking so well basically all the close encounters accessible from the northern hemisphere. We have the technology for doing this, and we also have the reason for that, because we really want to share those fascinating bodies with the people worldwide, especially with non-astronomers, because we believe that science, while done in scientific research centers, has to come back to people to improve their knowledge and enjoyment of life, and as well of nature. So asteroids here will be the topic, and in particular it will be near-Earth asteroids. Let me say a few words about Asteroid Day, but before doing that I would like to remind you that the Virtual Telescope has a few technological partners. I'm very happy to acknowledge every time. They are Unitron Italia Instruments, Software Bisque, Badr Planetarium, Santa Barbara Instruments Group and Planeweb Instruments. And I also want to thank ANSA Scienza in Tecnica, the most important press agency in Italy, and with them we have a very special collaboration for this kind of events. Also, as I said, but I still want to remind this event will have Michael Schwartz from Tanagra Observatories as a guest, and I want to thank him once again, and we will be with him soon. Well, Asteroid Day is a global celebration just willing to bring to people a wider knowledge about asteroids and a risk potential risk we can have from those very fascinating bodies. You know, in principle, if a small rock is orbiting around the Earth, it is possible, in principle, as I say, that its orbit will cross the orbit of the Earth. And what happens if both the Earth and the object are at that crossing point at the same time? Well, you can ask this to dinosaurs if they only survived to something like that happening 65 millions of years ago. So the asteroid day was intended on one side to increase, the knowledge, the awareness of people about asteroids, even because very often people outside astronomical observatories believe that we can receive a visit from an asteroid every day. And every time an asteroid is announced to come quite close to us, people have the impression that an asteroid is coming to hit us. This is not true. Luckily for us, the collision is a quite rare event. It happens from time to time, but not all the days, you know. And so the Asteroid Day wanted to increase the awareness about this so that people can better understand what astronomers say when an asteroid is coming to brush us from a small distance. It means it will visit us from a smaller distance, not that it will hit us. Also, Asteroid Day would like to increase the awareness of governments about this problem, and we really need to have more fundings for this kind of efforts. To date, a few people on this planet are on a constant basis looking for new asteroids, but also very, very few people are just doing some very important follow-up of those discovered objects. And Mike Schwartz is one of these great guys, just making sure that we will not lose those precious discovered objects. Discovered something and going to lose it the next day is just as discovering nothing, you know. And with those thoughts in mind, I have to say that Gregory Richards also managed to direct a movie inspired to the Tunguska event, and the Asteroid Day is today, the June the 30, because 107 years ago a small object exploded above Tunguska in Siberia, and it was likely one of the most documented, despite the long age now from the event, the most documented and studied event involving the possible impact of a small asteroid or maybe a fragment of comets. To be more accurate, there was no impact at all. We really did not find any convincing crater on the ground, but for sure it was a celestial object. And you know that about 2 years ago, it was 2013, something similar happened in Chelyabinsk again in Russia. So for some reason we had both events in that part of the Earth. All this to say that we really need to study asteroids. Okay, so let's share what we know, hopefully in simple words, and at the same time I hope you will find these objects not so scary but very, very intriguing. To be honest, asteroids are really a resource for us. They are the most pristine materials left around the sun since everything started around our star. 5 billions of years ago, the sun started to evolve from a larger diffuse nebula containing mainly hydrogen and helium, and the star we call sun today just was born this way. And all around the sun there was a lot of material, and that material helped creating planets, and collisions among smaller particles and smaller stones, let me say this, played a major role in making possible for planets to form. So after all, collisions among those small bodies is not something dangerous. It is simply something vital. Thanks to collisions, we are here. And let me say also this, asteroids are relatively new on the field of astronomy. The first one was discovered the 1st of January in 19 the beginning of the 19th century, it was 181, and it was discovered from Giuseppe Piazzi, Palermo, Italy. So it was an Italian discovery, the first asteroid, and it is now called Ceres, just after the goddess of Sicily, the island from where the asteroid was discovered. And to date, we know a lot of them. In a bit more than 2 centuries, we really increased the number of asteroids we know to the point that there are, let me say, about 500,000. So, a lot of them have a good orbit, but a lot of them as well as have less accurate orbits. And of course, not all the asteroids are just dangerous. If you just study how asteroids are distributed against the distance from the Sun, you will discover something very special. I want to show you this picture. This image comes from the Minor Planet Center, and it is just a distribution of minor planets against the same measure axis, that is the average distance from the Sun. If you look at this very simple plot, you will see that the horizontal axis is just showing some numbers as 0, 1, 2, 3 and so on, and the unit there is the astronomical unit. Saying 1, it just means the distance between the Earth and the Sun, while the vertical axis is just giving a number of asteroids. I mean, that plot is saying how many asteroids we have at a given mean distance from the Sun. And if you look there, you see that most asteroids are sitting between the orbits of Mars and Jupiter. And for this reason, we call that region the asteroid main belt. I mean, this is the city where the largest fraction, the largest part of the asteroid population love to live. And let me say this, if the Earth by definition is at a distance of 1 astronomical unit from the Sun, you see that for asteroids between Mars and Jupiter, we really do not receive any dangerous approach because they are orbiting very far away beyond planet Mars. This is in general, but depending on the shape of the orbit and other things, of course, the situation can be a bit different. And in fact, if you look carefully at this plot, you will see that some asteroids are orbiting the Sun with an average distance from the central star as the same as the one of the Earth, 1 astronomical unit or less. It means that those asteroids are spending a lot of time around the Earth orbit, and they are objects of interest for us on this topic. And if you look also at this plot again, you will see that the distributed asteroids are not populating the portion, the space between Mars and Jupiter on the same way. There are regions where you find asteroids and regions where you are not finding them. They are just some sort of forbidden regions, and we know that if you put an asteroid at that very special distance from the Sun, give it enough time and some perturbations, some disturbing gravitational effects by the big planets as Jupiter mainly and Saturn as well, will remove the object from that position. This is why you have some forbidden regions in the asteroid belt, and other regions are full with a lot of asteroids. And objects removed from those critical distances, providing a special interaction with the biggest planet, can be placed on a different route, probably leading them outside the solar system or even leading them inside the solar system, and the Earth is just living in the inner solar system. I want to show you another image again. Another image here from the Minor Planet Center, just giving you an idea of the traffic we have in the solar system. This is simple to understand. If you plot right now all the asteroids we know, and then you imagine to look from the above the solar system, you will see that A lot of them are between the fourth planet, and it is Mars, and the fifth planet, it is Jupiter. Something we have already seen in the other plot. But also there are a lot of asteroids, at least at the scale of this diagram, not far from the Earth. But also you have asteroids even more distant than Jupiter. And especially you have two very nice groups of asteroids living on Jupiter orbit. You can see a cloud, a blue cloud of them at hour 12 and another cloud of them at hour 8. They are the Trojans asteroid, and they are just moving together with Jupiter, a very special equilibrium conditions, and this is something we really like to study, even from a mathematical point of view. But I really wanted just to give you an idea about asteroid distributions, to show that if you consider all the asteroids we know to date, a lot of them basically, let me say 90% and more of them, of the whole amount of the asteroids we know, are just moving or safe orbits. This is enough to say that collisions are not happening all the days, you know. But at some point we realized that collisions can occur, of course, and this is not a field, an old field, because the first people just suggesting this started to pose the attention to this topic, I would say maybe 70 years ago, 60 years ago, on a systematic basis, I mean. And it was clear soon after that there were those objects crossing the orbit of the Earth. Not only asteroids were living between Mars and Jupiter, and it was an old story, but other asteroids are living closer to the Sun, where our planet lives too, and they can be sometimes a problem for us. And there are several classifications, because not all the objects coming closer to the Sun than an ordinary asteroid are of the same importance, and depending on the orbit of a given asteroid you can classify those objects. The whole family is named near-Earth asteroids. If you use the definition of near-Earth objects, you even include comets there. They are close relatives of asteroids. But I want to say that the huge family of asteroids has a small portion of them just approaching our planet to a given amount, and they are named near-Earth asteroids. And inside this small group you have other families like the Apollo asteroids, the Athena asteroids, the Amor asteroids, even inner-Earth objects, depending on the specific object. The Amor is just an object that will never cross the Earth of the orbit if you look at the relative situation between the asteroid and the Earth. The orbit of an Amor asteroid, which is part of the near-Earth asteroid population, will never cross the Earth orbit. Apollo will do, Athena will do, but the Athena are also very special because they spend a lot of their time inside the Earth of the orbit of the Earth, sorry. And finally, the inner-Earth objects are the most recent class among near-Earth asteroids, including objects with orbits entirely inside that of the Earth. They are very difficult to discover because an object completely inside the orbit of the Earth will never be visible, for example, at full darkness, because as Venus and Mercury, it will be forced to be seen around the twilight, because this object can never be far away from the Sun, and this makes their discovery harder. But of course they can be even of interest as for collisions, because if they approach enough from the inside the Earth orbit, they can be really a risk. I want to say that after some very important surveys in the 70s and 80s, years of the last century, the most significant surveys hunting for near-Earth asteroids are quite recent. And I want to show you another plot I just captured from the Jet Propulsion Laboratory. And this plot is just showing our discoveries of near-Earth asteroids increased over the time. To date, we know more or less 13,000 of asteroids, including every dimensions. But if you consider the objects with a diameter larger than 1 kilometer, you see that to date we have almost more or less 1,000 of them. And they are of bigger interest because the bigger the asteroids, the more serious the effects in case of collisions, of course. And we are continuing doing this, and over the last few years we had the impression, at least this is the impression of non-astronomers, that the traffic from asteroids coming close to us has increased a lot. That is just an impression. What increased is our capability to detect, discover small objects. Until a few years ago, if a very small object reached our planet, transiting even close, it was not easy to see it because technology was not good enough to grab it, to capture its very fast but dim light. Now we can do this pretty well, and this is why apparently, 1 or 2 times per month an asteroid is basically entering the orbit of the moon. But this is not because, as I said, asteroids decided to visit us more often, simply because our technology increased a lot, and we are happy for this. But we really need more and more observatories also doing this kind of surveys, of observations. Please consider this. We never know where an asteroid of this kind, near-Earth asteroid, will appear. For this, we have to scan very large areas in the sky, and we need very special telescopes for this. And this is why we really need dedicated instruments. A telescope with a large field of view, a big detector, and capable to reach faint objects, scanning very large areas of the sky on a nightly basis. And if you are able to do this, you will increase your capabilities detecting and discovering this kind of objects. But we have basically just a handful of projects doing this, and the two most productive ones, the Catalina Sky Survey, the Pan-STAR Survey, are both based in the northern hemisphere. So the southern part of the sky is partly uncovered because it is not visible from the northern hemisphere, and it would be great to have observatories there. Well, there was in Siding Spring, Australia, but for now it is not operational, and I hope this will be fixed somewhat and somehow. And this is why we need more and more. Also consider this: when there is bad weather at a given location, of course, it is hard to assure this coverage. When you are in the cloudy season, for example in Arizona, and Mike will likely also explain this to us, we lose the Catalina contribution, for example, and it is a pity that no others are just doing the same job from different regions of the globe with different forecast and meteorological conditions. And I want to show you also a couple of things that I believe of interest. You might remember that I mentioned the Tunguska event just inspiring this date, the 30th of June 30, today, as Asteroid Day, because the same day in 1908 something exploded in the sky above Siberia in Tunguska, and we realized that it was a celestial object. Considering what I have read about that, the explosion was incredibly strong, and the glare of the explosion was visible from London, so you can easily understand the power of this event. And I have also a few images showing the devastating effects of that explosion. Those brave explorers who decided to visit the site in Siberia were likely impressed by the landscape, with a lot of trees just on the ground because of the explosion, of course. I believe that this is a truly amazing, a truly shocking vision, but still a very, instructive vision, because from here you can really see in person the effects of these events. Of course, all around the globe we have very old craters coming from asteroid collisions, and those natural monuments to collisions, of course, are there, suggesting us to keep an eye to the sky looking for those potential hazardous objects. But I believe that going and check these images of the Tunguska explosion, the Tunguska event, is incredibly instructive, And another one still showing the effects of the explosion, and millions and millions of trees were just found on the ground because, of course, of the explosion. As I said, there were a lot of efforts to identify a possible crater on the ground, but if we we have no evidence for this. There were a few possible sites, but no conclusive proofs for that. So very likely this one exploded in the atmosphere, but the effect of the explosion was very, very strong, as you can see here. But even in much more recent times, again in Russia, in the Chelyabinsk city, with more than 1 million citizens there, you might remember this, in the 15th of February 2013, something similar happened, not to the level of Tunguska likely. Just can imagine what can happen if a serious asteroid explodes, even if small, like the Tunguska one, likely 15 meters of diameter, more or less. But if it explodes in Siberia, no troubles, no people is living there. But consider that explosion in a city with 1 million inhabitants. You can really have a historic record tragedy there. And the Chelyabinsk event was really terrible, because we had a clear evidence that a little bigger asteroid could be really reason of a catastrophic event, at least for a city like that, even if small. And it is impressive to see the images we have from the Chelyabinsk event, a lot of images, because in Russian the cars have a camera on their front part, just surveying the traffic in case of accidents, and those cameras provided a lot of images with the meteor, very bright meteor, just illuminating and blinding people because it shined a lot. And this one is an image coming from someone in Chelyabinsk. And also I was impressed to see the smoke in the atmosphere. When the press agencies in Italy called me that morning, I was truly impressed, because looking at the images while I was still sleeping, I could not believe that it was an asteroid. It looked as a war scenery, but it was a natural body. So what I wanted to say to you in this introduction is this. We know asteroids. They are small objects, mainly living between Mars and Jupiter. They can have dimensions from a few centimeters to 1,000 kilometers and more, but until they are in between Mars and Jupiter, they are not trouble for us. But some of them are moving on orbits, bringing them in the inner solar system, and they can pose some threat to the Earth. And those asteroids, that we call, for obvious reasons, near-Earth asteroids, deserve a lot of attention because while to date we do not know any asteroid in risk of collision with us, soon or later we can find one of them, and at some point we will have to face this emergency, and we have to invent something to remove the collision risk. This is also another fascinating story. But as I say, right now we have a very few projects worldwide hunting for near-Earth asteroids, and after that one of those objects is discovered, there is also another very important job to do, that is tracking it, recovering it. Otherwise that discovery is lost, is useless. I will not spend enough time underlining this. If you discover a near-Earth asteroid and you will lose it 1 year later, well, the discovery is useless. You really don't have benefit from the discovery. So this is why I believe that the follow-up of near-Earth asteroids is as important as the original discovery. Well, after this, I would like just to introduce you to our guest, and I was so happy to remind you that our guest is Michael Schwartz from Tanagra Observatories, and I'm just opening the audio for him so that Mike can just jump into the conversation. Hi Mike, can you hear me?
Yes, I can hear you, John.
So Mike, I want to welcome you on this live event. I see a lot of people from everywhere around the globe joining our event for Asteroid Day, Mike. And as I told to our audience, you are a pioneer in highly automated robotic astronomy, just to maximize the efficiency of the observation and the science coming from that. But I would like to kindly ask you, Mike, if you can shortly introduce you and just to tell us how you started working and your interest in astronomy.
Okay. First of all, I would like to thank Professor Mazzi. His work in public education is very, very rare, and the amount of work it takes to do this kind of worldwide broadcast, as well as making his telescopes available for the world to see at no cost, this is exceptional. And it's very difficult to appreciate the amount of technical knowledge it requires and how much effort it requires. So I would like to personally thank Dr. Mazzi for doing what she does.
Thank you, Mike.
I am very, very impressed with it. I began Tanagra Observatories in 1997. My immediate interest was two things: discovering new objects and somehow teaching a telescope to run by itself all night so I can sleep, and the next morning to look at the data and see what I have discovered. I started out with a very small telescope, and this search I began was for supernovae, which are exploding stars in other galaxies. At the time, it was not accepted by most of the professional astronomers that it was possible to do this with a small telescope. And one of my challenges was to show them that they were wrong. So I discovered quite a few supernovae in other galaxies, and each time was a great excitement. Forces with Lick Observatory in California, out of University of California, Berkeley, and together we cooperated to split up the sky so we were not looking at the same galaxies. So I had what I was looking for, which was discovery and ways of making a telescope work automatically. Not only does this let me sleep at night, but it is very efficient. The telescope moves to a specified area, it takes a picture, it moves then to another area, so there is no one sitting there at the keyboard saying, move here, and then giving the telescope camera a command to say, take a picture, then having to save the picture. If all of this is automatic, then you can cover many more objects per night. From there, I moved Tanagra to southern Arizona, where we have about 300 clear nights per year, and I obtained larger telescopes. In this case, 2 telescopes. One of them has a mirror of 0.8 meters and is made to look at a small part of the sky. The other one has a mirror that is 0.4 meters and is made to look at much larger pieces of the sky. So each one is a special instrument. My interest in asteroids continued, but I also needed to help support the university, so for some years I sold time through the internet, and Tanagra was one of the first observatories to connect with universities through the internet to help support the observatories. And when there was free time, then that was the time that Tanagra would observe asteroids, search for comets, and at the time do some more supernova searching. So that brings us up to the present. I would also like to mention that this day, June 30th, is Asteroid Day, and while most people are rightfully showing interest in asteroids that may hit the Earth, we must remember that asteroids are left over from the very, very beginning of the solar system. And to understand them, we will understand the beginning of the solar system. And so there are many ways to study asteroids that don't involve looking for those that may hit the Earth. And asteroids come in different kinds. A lot of them have small moons going around them. Some of them are very large, and luckily recently we have had pictures of the 2 largest asteroids. And currently, out of University of Arizona, there is a project to send a space probe to an asteroid, collect a sample, and bring it home so it can be analyzed with the best possible equipment. So the celebration of asteroids is more than collisions, although collisions are a very important topic right now, and is one of the reasons why all over the Earth today people are discussing the possibilities, what we can do about it, and how we can gather more pictures of the sky from all over the Earth to try to cover the sky as much as possible. At the beginning of this year, January 1st, 2015, I was able to get a grant from NASA so I could devote 100% of my time to observing asteroids, and specifically the near-Earth asteroids. Before that, I had some time, and since I love discovery, I managed to find, with the small telescope, 11 comets, and yes, some are named after me, and these are very exciting objects to look for, especially when there is very heavy competition from much, much larger telescopes. Now, my current work, unfortunately, is not to discover. This is left to the bigger telescopes. But what the bigger telescopes have not been doing is to study them more after they have been discovered. So what does this mean? This means that if you simply discover it on one night and you measure how it changes and moves compared to the stars that don't move, you can only get a very rough idea of where this asteroid is going and when it's going to come back. And so the NASA grant has me taking the discoveries of larger telescopes and following them as long as possible. This allows the orbit of the asteroid to be much better calculated, and eventually, when it comes around again, the amount of sky that we need to look at to recover this asteroid is very small. Now, unfortunately, since there's been much competition among discoverers, there are many asteroids out there that were measured only for 1, 2, or 3 days. And when I speak about these, again, I'm talking about near-Earth asteroids. So what this means is, since not enough information was collected to predict where it would be in the sky when it came back, someone has to take pictures of large parts of the sky and look for these lost asteroids. And that is the second function of Tanagra Observatory, is to look at large section of the sky. We can calculate roughly where it is, but sometimes the data is so bad that it can be a fairly big piece of the sky. So we have to take many, many pictures and analyze these and recapture this asteroid, measure some more, and then finally get a good idea of the orbit of the near-Earth asteroid and determine whether or not it will be a dangerous asteroid. So essentially, that's what happens at Tanagra observatories. I'm a very lucky person to be living in southern Arizona. I have my home here. I have my observatories around the home. And I live in a beautiful place in the desert. As Dr. Mazzi mentioned, unfortunately, I'm entering the season of rain, which is from about July 1st to September 15th. And during this time, very little work can be done. But at other times, those 300 days, there is a tremendous amount of clear skies. So how does this work? At the beginning of the afternoon, the asteroids that have been recently discovered by the large telescopes have been reported to the Minor Planet Center, which is in Massachusetts, and this is the center of distribution of all asteroid data taken from all over the world. So depending upon how fast that near-Earth asteroid is going, excuse me, and in what direction it is going, we determine which ones need to be studied most. At the same time, the smaller telescope is going to look to recover lost asteroids, and so this list is made late in the afternoon and into the evening. This list is fed into the computers here. The telescopes will start automatically by themselves. They will open up and begin doing the observations that the input data has told it to do. Then I go to bed. After that, and during the night, the telescopes protect themselves. They're connected to instruments that can measure whether or not there are clouds. There's an instrument that measures if there's a raindrop. If this occurs while the telescope is automatically working, then they will close to protect themselves. At one time, and this happens occasionally, of course, a telescope has a problem. If it has a problem, it calls me on the telephone and plays the Beatles song, Help. So I know to get up and see if I can pay attention to this problem. I have to say, after all these years, that I have come to hate the Beatles song, Help. But it's necessary. So a lot of data is gathered by the telescopes as they move by themselves during the night. This data is fed into another computer program which is automatically looking for the moving asteroid. Now, the way we can tell that we have an asteroid is essentially it moves with respect to the stars. And this movement is a combination of the movement of the asteroid as well as the Earth's motion around the sun, as well as the Earth's rotation. So during the night, there is a program that is looking at all the pictures and is automatically detecting the objects that are moving. So morning comes and the telescopes automatically close. Then after that, I look at the results of the analysis that was done during the night. And some of the results are very obvious. In other words, if I'm following a particular asteroid, then it can automatically look at the data that has been taken about this asteroid and automatically know that it is the asteroid that was chosen to be looked at. So this happens automatically, and then it gets sent to the Minor Planet Center, which again is in Massachusetts. It is the place where all the world's asteroid observations are reported. Occasionally the computer program makes a mistake and it will tell me that it is not sure, and then I have to look at these on the computer screen and decide it may be a defect in the camera. There are all kinds of reasons that we get false detections, but luckily if you have a very smart computer, only about 10% of the asteroids that have been found need to be looked at on the screen. And during this whole process, if I need to look at the screen, the program, once I choose the asteroid, will again automatically send a report to the Minor Planet Center. So, to sum up, my job is to collect as much information about newly discovered asteroids and locate asteroids that have been lost because no one followed them for too long after they were discovered. This is a very good life. I enjoy it tremendously. And even though there are always problems, something breaks, whatever, it's a good life, it's an interesting life, and a good place to be in astronomy right now, and a very interesting topic. Dr. Mazzi, would you like me to move on to the possibilities of what can happen with a encounter with an asteroid?
Yes, Mike. I was happy to listen to you about this, and I wanted to ask you if you can just give you some hints, and also what are your thoughts about asteroid hazard. This is a topic that I would like to discuss a bit with you. Thank you.
I'm sorry, my tools for what?
I would like to have your thoughts about the asteroid impact risk. What do you think about this? I mean, when you are doing your job, are you confident that you are doing something helping the world understanding better the collisional risk?
Yes, because once you improve the orbit with more data, you can tell, especially when we come back to that asteroid returns to us, we can tell whether or not it is what's called in the business a PHA, a potentially hazardous asteroid. So in this way, by collecting all the extra data, the possibility of collision can be given a much higher value. Of course, most of them turn out that they will not have a collision with the Earth, but you never know that once you improve your knowledge of the path of the asteroid, whether or not it could possibly. So this is the exciting part, that Tanagra can help and has been given funds from NASA in order to determine what will be a potentially hazardous asteroid and what will be a harmless asteroid that for many tens and hundreds of thousands of years has no possibility of hitting. It has rules. For instance, we have not found any place where there is gravity that if you drop a ball, it goes up. It falls. So this means whatever we study on the Earth, and if we study chemicals like hydrogen, they behave according to rules. So if we see hydrogen in other stars, we know how the hydrogen would behave. So as a member of the cosmos, knowing that these rules exist is very important to me. Not only that, it's very practical. Now that these rules are uncovered by science, it is possible to apply them every place else that we look in the universe. Most importantly, I feel a member and a closeness to the universe. And I also feel the beauty of tools that humans have uncovered to see that these rules apply everywhere in the universe. To me, this is a beautiful thing. It is an emotional thing. It is a journey. It is traveling. And we need to take time to step outside and look at the stars. Most astronomers sit in a room and look at a computer screen. For example, on the 24th of June, Jupiter and Venus will come very, very close together during sunset. And I will certainly be outside looking through a small telescope to see how beautiful this is. So, to me, science is a combination of beauty and wonder as well as study. And many other scientists feel the same way, although often they are not asked about this because people want to know the specifics of their work. But it is most important to me that I am a member of the cosmos, and it is a beautiful, beautiful thing.
I really agree, and I really like your point of view on this, because many people believe that because of the very advanced technology we use in science, there is no room for this human feeling. I mean, even when we talk about asteroids, because of course we study them from a scientific point of view, but after all it is our human beings pushing us to look for them, to study them, because after all we want to avoid that an asteroid will hit us without knowing it. So after all, it is our human being motivating our scientific adventure, and I strongly share your point of view, Mike. This is just great for me. And I would like to kindly ask Mike, now that we are approaching the end, what do you see in your future? I mean, would you like to develop further your engagement with the near-Earth asteroid science? Would you like to do something different in astronomy? I would like to know if you have ideas on this.
I think at this point in my life, and I will be 65 years old in October, I will end my astronomical studies with near-Earth objects. My NASA grant goes for 3 years, and we've been very, very successful, and our telescopes will be replaced and improved, and I can always get a continuation for another 3 years. So I think at this point in my life, after having studied many things, from the evolution of galaxies to cosmology, that this could be the last step in my astronomical career. But then again, I'm not speaking as if I'm 27 years old, and I do have some other things that I'm very interested in as well. And since we don't live forever, and we return back to star stuff, because after all, our molecules were made, our atoms were made in stars. I will return back to star stuff, eventually become part of another star or planet, but at the end, no one knows what happens, but I think this will be my last emphasis in astronomy, and I hope when the time comes that there are people who will take over my equipment and will continue the work. But I think I will continue for 3 to 6 more years because there is so much to be discovered. There are so many new telescopes being built. The asteroid impact question is only beginning to be answered. We're at the very, very beginning. There are so many unanswered questions. So much depends upon the size of the asteroid. So much depends upon where it falls to the Earth. So much depends upon finding it early. There is currently no method to send any kind of space vehicle to an asteroid to get it to move so it does not hit the Earth. So what is coming is very, very exciting. And I would like to be part of that.
That is great, and I really am looking forward to see you and Tanagra observatories providing that amazing job that for more than a decade you actually offered to the scientific world. I want to say that a number of years ago I was also happy to use Tanagra observatories for some research, and I must say that it was your amazing project that actually pushed me to explore what technology could do. And for me, having this joint discussion with our friends listening from home has been a pleasure and a privilege, because not only I've been talking with a good friend, but I've been talking with a man who made very important advances in astronomy, putting together astronomy and technology, and also now continuing with these efforts and just adding more and more both to the scientific side and the human side, because as Mr. Schwartz told us, he is a curious person, and astronomy is just an excuse to develop and feed that part of his nature. And I hope that everyone will enjoy the night sky, nature, life in general, and asteroids. If this will happen, will not be something to fear, but something precious, promoting thinking, promoting shared knowledge. And for me, Mike, this is a wonderful message.
Yes, and I want to remind everyone that scientists are not calculating machines.
You're right.
Scientists work from imagination and intuition. It is not uncommon for a great scientist to have a great idea while taking a shower.
This is great.
The same kind of inspiration and intuition is used in the arts. It's used in all creative endeavors by human beings. So while people may see science as mathematics and machines, they have to realize that the source of ideas and discovery comes from the same place where an artist works with his paintbrush, or a writer writes with a pen or on his computer. It all comes from the same place. And virtually every great scientist known to history has felt open to say that this is true. So I encourage everyone out there to use their imaginations and to believe that they are truly an equal member of the cosmos and appreciate that fact. I would also like to add that I welcome any questions by internet. If you Google Tanagra observatories, you will certainly come to my email sooner or later, and I will answer each and every question sent to me, because at this time in my life, I especially enjoy what Dr. Mazzi is doing. I feel like it is time for me to share. And please do not hesitate. There is no such thing as a silly question. And sometimes the questions are very good, and I do enjoy answering them. So this is a very sincere invitation to those who are listening to please send me your questions, and I will give them my full attention.
Thank you very much, Mike. I want to remind our friends connected that you can discover Tanagra observatories at www.tenagraobservatories.com. From there, you can even surf the many discoveries Mike made over the years. Well, I cannot find a field where Mike didn't make a discovery. He discovered everything everywhere. I remember even very rare objects found during his surveys, and also a number of comets, supernova, very rare dwarf novae, and asteroids, and so on. And for me, acknowledging his availability to share with people what he knows, what he loves, what he's doing is for me just fabulous. And for me, it has been really an inspiring motivation. And I want to thank Mike for being with us. And you can even follow Tanagra Observatories on Facebook. And also Mike is a very nice, great photographer. And you will find on Facebook too his photography special fan page. So just look for Michael Schwartz, Tanagra Observatories and Tanagra Photographs, and you will have a lot of interesting things to check. So thank you very much, Mike, for your time. I'm looking forward to talk with you again, and of course I wish you a very nice, enjoyable and fruitful work at Tanagra Observatories.
Thank you so much for having me. It's been a real pleasure. And to everyone all over the world who is listening, keep looking up. Remember, you are an important member. Enjoy the possibilities that Dr. Mazzi offers through looking at images of many things through his free telescopes, and don't be afraid to ask questions. We are all on this little blue-green planet together, going through space, going through the galaxy. We are all holding hands. So let's continue to do that, and let's increase it. So thank you everyone very much. I've enjoyed myself. And Gian, it's been a pleasure. Thank you for inviting me. Everyone enjoy their evening, and I hope to hear from as many of you as possible.
Thank you very much, Mike. Once again, we will keep in touch for sure, and I'm sure in the future we can repeat this nice experience, and we will have both fun and a good time together. Good evening, and see you soon, my friend. Goodbye. Thank you.
Okay, goodbye. Thank you.
So, friends, we had a very nice time with Mr. Michael Schwartz from Tanagra Observatories. I was so happy that we were able to spy him a bit closer, understanding the job he is doing under a very important NASA grant he received, and now making possible for him to reserve his energies, effort and knowledge for near-Earth asteroid studies. Well, it has been also very good for the virtual telescope to host this marvelous event. Once again, I want to thank my guest because he really added something special to this. And unfortunately the weather is not clear, so I cannot go with some live images as I wanted, and for this I just would like to show some asteroids we observed with the virtual telescope recently, and because at least I can just show you how an asteroid looks like when seen through a telescope. And as Michael Schwartz explained us, we need some very important technology just to trace asteroids moving across star fields, and there is some serious analysis just to have the system able to perform that search automatically. And even in that case, as Michael told us, you have to check from time to time in person, so the human factor is always present on one side because you programmed and created the technology, and also because some critical cases requires your action, of course. And here I really want to show you the asteroid Icarus. This is an image we just collected about 2 weeks ago, and the asteroid is very well visible in the center of the field of view, and the telescope was tracking there the asteroid. This is why the asteroid is looking as a sharp dot of light, while the stars are just sliding on the background. And I must say that recently we planned a number of events covering the latest brushing asteroids, but the weather has not been the best we wanted. Here it is, another wonderful object. This is the 2015 LF object. When this one was imaged, this object was well inside the orbit of the moon. You can see it was at 270,000 kilometers from our planet, and once again the virtual telescope was able to track these quite carefully. But for many reasons, the record object we ever tracked at virtual telescope was this one. It is a 2012 DA14. This one arrived closer than geostationary satellites, so closer than 36,000 kilometers from us, and virtual telescope was one of the very few observatories in the world to track it carefully. I mean, the telescope was prepared to track the fast apparent proper motion of this object, moving at 0.6 degrees per minute at the imaging time, and this one made the virtual telescope quite famous in the world because this image really was shared a lot around. So friends, I think that we are finally approaching the end of our coverage. We wanted to celebrate Asteroid Day today, and we were also happy and proud that the Asteroid Day organizers kindly asked us to join this effort, and we were very happy to provide our support for such online event. I want to thank Grigory Richters, of the founder of the Asteroid Day movement, for considering us for this important task. And I want to thank again our guest Michael Schwartz, CEO and founder and president at Tanagra Observatories, and he is leading the world of robotic, highly automated astronomy. And I also want to thank the technological partners of the Virtual Telescope project. Namely, they are Unitron Italia Instruments, Software BISC, Bader Planetarium, Santa Barbara Instruments Group, and Planewave Instruments. I also want to thank ANSA, Scienza and Tecnica for just organizing this event jointly with the Virtual Telescope project team. So this is that's all, and I want to tell that of course the language was English because of the international nature of such a coverage. I hope that you enjoyed it. If we had some little technical problems during the live coverage, I apologize for this. We are continuously working to improve your experience. And tomorrow we will try to show live online the wonderful conjunction between planets Venus and Jupiter. If you want to see it, come back again, same website www.virtualtelescope.eu at 19 Universal Time. That's all, so thank you very much. Gianluca Masi from the Virtual Telescope is wishing the very best to you. Goodbye and keep looking at the stars. Goodbye.